At the end of the lesson, you are expected to identify the step-by-step modeling process using matrices with real numbers, make a predictive model using matrices with real numbers, and appreciate the significance of matrices in predictive modeling. Okay, this time we're going to work with a numerical example. So I think not all of you are really very familiar with working with vectors and matrices. So if you want to learn more about working with vectors and matrices, the link of the previous lesson is given in the description below, so please check this one. Learning this lesson would be more meaningful and more exciting if you know already how to deal with vectors and matrices in modeling. Okay, so we are still going to do the synthetic linear regression again. So we have this data that is presented in matrix notation, but we have matrix X here, and then we also have matrix Y here. So for you to clearly understand the story behind these numbers, this is how it goes. So listen very carefully. So we have here 3 customers. We have first customer, second customer, and we have the third customer. So each customer represents a function. So for the first one, this is function 1, this is function 2, and then this is function 3. Then we have 2 columns, and the columns represent the attributes. The first column is the quantity, and the second column is the amount paid. So we are still considering here sales data. And then the matrix Y here is the sales. So what we're going to do is that we are going to build a model that can predict our future sales. So before we continue, please hit the subscribe button to enjoy more our deep learning, machine learning, and natural language processing lessons. So please click the notification bell to be updated of what's going on, especially if you're going to download the new lesson. So we're going to go to the step-by-step process. So I think this one is very much clear. So let's go first to our step number 1. So what is happening in step number 1? So let me use this one. So in step number 1, what we do here is that we multiply the transpose of x and then the x itself. So the transpose of x is 1, 1, 1, then 1, 2, 3, and then this is our x, right? Our original x. Okay, so the first column becomes the first row, and the second column here becomes the second row. Then when we multiply that, this will give us 3, 6, 6, 14. But just to give you some knowledge on how we get all of these, so let's have 1 times 1, 1 times 1, 1 times 1, then we add up the products, then that give us 3. Then 6 here is 1 times 1, 1 times 2, 1 times 3. So when we add all the products, that will give us 6. So the same process with respect to the second row. So we multiply first this with the first column and then with the second column to get all the values here in our second row. Okay, now after we get this number 1, then we are ready to go to our step number 2. And what do we do here in our step number 2? So basically in step number 2, we're going to get the inverse of step number 1. And what do we do in step, or what do we do to get the inverse of this one? So how do we get 1 over 6? So 1 here is the what to call this one? It's the, okay, it's there, right? So, and 6, how do we get number 6? Okay, or 1 is the constant, I get it. 1 is constant, and how do we get 6? So very simple, 3 times 14 minus 6 times 6. So that becomes 42 minus 36, then that gives us 6. Okay? Then here, as you could see, the terms in our diagonal, we just switch the places. Then 3 becomes the upper one, and then 14 becomes the lower one, as you could see here, right? Then let's change the signs for both items here. Okay, so because it's positive, then it becomes negative. Okay, so that's it. And with this, we are ready to go to our step number 3. And what do we do in our step number 3? This is more elaborative because we combine more matrices. So what do we do here is we are going to multiply the inverse with the transpose. So this one and then this. So if we're going to do the process of multiplication, we're going to get this one. And how did we get this? It's just very simple. So of course we will just copy this one, okay, and we will know later how this one is used. Okay, but for the meantime, we're going to multiply only the terms here and then the terms here. So 14 times 1, that is 14. Then negative 6 times 1, that is negative 6. So 14 minus 6, that will give us 8. Okay, then 14 minus 1, that gives us 14. Negative 6 times 2, that is 12. So if we're going to do the process, that's 14 minus 12, then that gives us 2 here. Then 14 times 1, 14. Negative 6 times 3, that is 18, or negative 18. Then do the process, 14 minus 18, that gives us negative 4. And for the terms here, these are taken by multiplying these terms with these terms. Just the same process. Okay, but we're doing that with the second row. So we get this for our step number 3. Now, after having this, we are ready to go to our step number 4. And what do we do in step number 4? So basically, in step number 4, we are going to multiply the result in step number 3 with the value of our y. So let's go back. The value of our y, and again, this represents our sales. Okay, so what do we do in here is that, again, so when we multiply this and we're going to involve the value of 1 over 6, this will give us this one. Okay, so 8 times 13.8, then 2 times 10.2, negative 4 times 4.5, then we're going to divide that by 6, then this will give us 5.47. Then for the term here, negative 3 times 3.8, 0 times 10.2, 3 times 4.5, we add up all the products, then we're going to divide that by 6, then that will give us 0.35. Okay, so what do these numbers here represent? So remember our parameters, how we do the parameters. So this is actually 0, 1, our first parameter, and this is our W1. So this is our second parameter. So that means if we are going to make our formula or our model, then we have this model. So let me write here. So we have 5, I think it's working, 5.47, okay, plus, and we have 0.35x. So this is the value of, this is the value of our y. So y is equal to 5.47 plus 0.35x. So now, this is our model, a simple linear model that can be used for prediction. What is this for? Why do we have to study this? In a lot of machine learning applications, we can deal with a lot of variables, hundreds or even 1,000. In this regard, a simple use of listing of numbers in a series cannot give proper result. So using matrices and vectors is the proper way. So this can give us more accurate results. After all being said and done, let's try this. Build a predictive model using these matrices. So we have matrix X 1, 4, 2, 3, 1, 5, matrix Y 10.2, 13.5, 9.8. So leave your answers in the comment below so that we would be able to have a very rich interaction and exchange of ideas so everybody can learn from each other. Do you want to know more about this course? Just click the card on your right screen. You can enjoy our deep learning machine or mastering machine learning algorithm and natural language processing courses. Learn and upskill for free.